Hi, so this video, I'm going to show you guys how we're gonna um, convert the raw file that we downloaded from the Open Model Zoo, which is a VG19. If you follow my previous video, so we will be using the model optimizer. Uh, Inside the model optimizer, inside the OpenVINO, there is a model optimizer script which you can use to convert the raw pre-trained models into um, the IR file, intermediate representations file, which consists of .bin file and .xml, which is needed to run the inference in our OpenVINO toolkit. Okay, so you need to go to the model optimizers folder. So it's under deployment tools. So if you go to the model optimizer, so you can see that we have a model optimizer.py. It's a .python extension. So we also have model optimizer dash cafe dash caldi mxx onx and tensorflow. So basically, if you know that your model is a cafe model, you can also use this Python script. Okay, so for this video, I'll be using the model optimizer.py. So same thing. If you are not sure what is the command that you need to run this Python script, you can always go to this using the help command. Okay, so the help command, you can see that there's a bunch of list of explanation and command that you can use to run this model. For example, input model, model name, output directory, input shape, and etc. Okay, so we are good to go. So we will be using this Python and mo.py. Then you need to tell them the name of the data type, the data type. The data type that I'm going to give is I'm going to generate is a 14.32 FP32. The name, model name that I'm going to give is a VGG19 underscore 14.32. And the input model will be the location of where you download this VGG file previously. For myself, I download in this link, so I just copy this path. Um, then the name of the file, which is vgg19.cafe. So I just copy the whole thing. Okay, and then you need to tell the script where you want to output the generator file, output directory. So output directory, I'll be generating under the path that I choose. So this is really depend on where you want to output the generator file. So I'll be outputting in this path. Okay, so we are good to go. So just click enter. So you can see that the position of alpha is 14.92. Input layer, output layer. So this shape we don't really specify. The folder output name is a VG19-14.32, which I tell this script the name that I would like to generate, and also the path to the input protect files, path to custom layer, and yeah, the path to the input model. Okay, so it might take some time to run the generation. Okay, so if successful generate the IR file version 10 model. So XML file is located here, VGG19 bin file. So total execution time is 42.98 seconds. So you can go to the model that we generated. So you can see that I've generated VGG19 underscore dot FP32 bin file XML file. So these are the two files that you need to run the AI inference. Okay, so another question you asked, so what's the difference if I want to generate, how do I generate a 40.16? So it's pretty much the same. So you just need to tell the script that you want to generate the data position of 40.16, and I just change it to 16, and also the name. Of course, you want to differentiate the name between for the file that you generated for 14.16 and 40.32. So you just click something like this, then you should be able to see that it's generated. So it might take some time, it's less, but it's basically less than 1 minute. Okay, so we have generated the VGG underscore 40.16 and 40 .xml and .bin file. So if you go to the model, the folder that you generate, you can see that I have generated 40.16 and 40.32. And you can see that the size generated, the model size generated is totally different. 40.16 is only 280 meg. VGG 1940 with 40.32 is 561 meg. Okay, so that pretty much conclude the video for this time for the model model optimization or model conversion.